Good day, I am Regella Anasabas of 12 Del Castillo, and this is my video presentation of my chosen experiment, Hooke's Law Springs Virtual Lab. For this experiment, here are our objectives. Next, this is the material needed, the website for the Hooke's Law Springs Virtual Lab. This experiment is knowing more about the concept of Hooke's Law and the principles behind it by using a virtual interactive simulator. The first part of the experiment verifies the relationship between spring force and displacement, while the second part involves spring combinations, parallel, and series. Here are the following experimental setups for Part A, Part B, parallel springs, and Part B, series springs. Here are the data and results for Part A. The preset value of spring constant here is 200 newtons per meter. As the spring is stretched to the right by the applied force, the table shows that the amount of stretching in x meters is positive and spring force is negative. Inversely, as the spring is compressed to the left, x is negative and spring force is positive. Since the displacement is in the opposite direction of the spring force, this is mathematically stated as negative x. With this, the graph has a negative slope as well to represent such statement. The same goes for the data and results for Part B, parallel springs, where the displacement is in the opposite direction to the spring force, as it also obeys Hooke's law, only that it is a parallel spring system. There are two spring constants. K sub 1 is 450 newtons per meter, and K sub 2 is 550 newtons per meter. So the spring constant for springs in parallel, or K sub parallel, is the sum of K sub 1 and K sub 2, which here is 1000 newtons per meter. Once again, the same goes for the data and results for Part B, series springs, only that it is a series spring system. Using the same two spring constants, the spring constant for springs in the series or K sub-series is different as seen in the calculations. In all the parts of the experiment, the experimental value, which is the absolute value of the slope of the force position graph, has the same value with the true value, which is the preset value of spring constant, the sum of the two preset values of K sub 1 and K sub 2, K parallel, and the values of K series in parts A, B parallel, and B series, respectively. Thus, the absolute error for all parts is 0. Beyond an experimental setup, Hooke's law can be seen in different real-life applications, such as in mattress spring beds and in innovations like the lower limb exoskeleton for human walking, where both use springs to ensure safety and comfortability. Taking all of that into account, here are the conclusions at the end of the experiment. Then these are the recommendations because it is acknowledged that the virtual simulation may not be accurately similar to an in-person setup and that human errors upon putting an input on the virtual simulation are still possible. Now this is the end of my video presentation. Thank you so much for watching.